the risk and the determining factor is just generalization. Like, is my device and architecture generalizing enough that most users will be able to use Glide in most environments? That's a huge ask.
It is.
From a robot. Like, there's no other robot that you'd put that ask on, right?
No, that's true. Yeah.
So that is really a lot of our work right now, is to understand the generalization, especially on the AI platform.
This episode is sponsored by NXP Semiconductors. NXP offers a comprehensive combination of advanced AI and machine learning solutions, sensing technologies, edge computing, robust connectivity, and networking solutions. Critical to the development of physical AI, the company also provides integrated security and functional safety. Together, NXP is powering the brains, muscles, and nerves of autonomous robots. Learn more at nxp.com/AI.
A man stands outside with a leafy backdrop. He's facing the camera and wearing a black shirt with bold letters that say, "Let's glide."
My name is Amos Miller, and I'm the founder and CEO of Glidance. I lost my sight from retinitis pigmentosa. By my mid-20s, I lost all of my sight. The big question was, how do we get more blind people out and about through the power of advancements in technology? What we need is a device that is physically connected to the ground and that physically guides the person.
Hi, my name is Junko Yoshida. I'm the editor-in-chief of Junko's Talk to Us. This is the video podcast series. We are focused on physical AI. And today, actually, we have a great guest, Amos Miller. He is the founder and CEO of Glidance. Hi, Amos.
Hi, Junko. Wonderful to be here. And
Great.
Founder and CEO of Glidance.
Yes, very good. So with us, we also have Ron Wilson, my partner, to pursue this physical AI series. He asks a lot of hard technical questions, and I ask a lot more friendlier questions, I guess. But no, kidding aside, I find this topic of physical AI quite interesting in a way that it was so overhyped, in my opinion, during Consumer Electronics Show. I don't think people really understood what physical AI is. And the reason why I'm so excited to bring Amos to the show is this is sort of like a living example of putting physical AI to practice. Amos, you can start sort of explaining what exactly your product Glide does first.
At Glidance, we started to explore the question that I personally have been looking at for some time about how we can harness the power of AI and robotics to improve lives of people with disabilities, and our focus has been predominantly on people who are blind, and how today the great majority of blind people, the only option that they really have is a white cane or a guide dog to be able to get around, but only a tiny proportion of blind people actually do. It can take many years to train to use a white cane. Availability of guide dogs is very limited. So what I started to look for is what would be a new kind of mobility aid that will enable a blind person to get back on their feet much more easily.
Yeah, so that was the starting point. I'm sorry that I should have asked the first place what inspired you to found this company, and that should have been my first question. So you kind of answered that, but you yourself weren't blind when you're born, right?
So I I am blind. I actually was born with a genetic eye condition, which meant that I was actually sighted in my early life. So I lost the majority of my sight in my early 20s while I was in computer science, doing my computer science degree. So that was a bit of a fun experience at the time, learning to figure out how to use a computer with ever diminishing sight and getting around campus and then finding a job. As a blind person, yeah, that's definitely part of my lived experience here.
So there are options like using cane, also guide dog. I thought guide dogs is the solution, but obviously
Right.
they're not that widely available, right?
Guide dogs are incredible partner companion for a blind person to get out and about. Um, the challenge is that in order to be able to use a guide dog, you have to be a very competent cane user. And then it's a very high cost. Basically, it can cost up to $100,000 per dog. Whether it's the blind person who pays for it or whether it's paid for through donations or other ways,
Right.
the cost is very high. So, for example, in the US, there are somewhere around 7 million people who are blind or have severe sight loss, and there are 10,000 guide dogs. It's completely out of proportion, right? And the schools that train dogs and train people work very hard, but one of the biggest schools in the US can train 200 dogs a year. 160 of those dogs goes as replacement for dogs who got older. So there's only 30 or 40 new people every year are able to get a guide dog. And so it's simply not scalable, right?
Yeah. Yeah. Did you yourself actually have a guide dog or no?
I'm on dog number 6. I've had lots of dogs throughout my life, yes. And
All right.
yeah.
So fundamentally, what did you expect your smart cane to do equivalent, which you perceive as equivalent to the smart guide dog?
I'm gonna answer this question from 2 angles, okay?
Okay.
The one angle is how do we get to par with a guide dog or another mobility device, yeah? And that's when you go from the ground up. A mobility aid has to first of all, it has to physically guide. And that's something that a lot of people will argue about. Okay.
Mm.
It is like people say, why can't you just put smart glasses and follow where they're going? Okay. And the thing is that our brain is not geared to move based on instructions. If you're going to walk, if you're standing in a corner somewhere and there's a door, let's say in front of you and to the right, and there's a whole bunch of planters and tables and chairs in between you and that door, nobody is going to be able to, if you're going to close your eyes and somebody will say, okay, let me guide you towards the door. Walk 2 steps, turn a little bit to the left. No, a little bit more, 2 steps forward, a little bit to the right, 3 steps forward. Like you can see that that's going to break very, very quickly. We tried to do that with audio, like directional audio and amplitude of audio. We tried to use haptics to give. The brain isn't geared process that kind of information fast enough to affect your motor system and actually. So it becomes a question of if you had the best AI in the world that saw the door, saw the obstacles, knew exactly where to guide you, was your best friend, your best agent, knew exactly what your life, your favorite ice cream time, how is it going to guide you? How is it going to physically show you the way? Yeah. And so the conclusion to that I arrived at, which is proving to be very promising, is that you need something that is physically connected to the ground and physically guides the person. One day we might be able to plug directly into the motor system in the brain. When that date comes, maybe we'll have other solutions. We are not there yet. So we need something that is physically guiding, physically avoiding obstacles, but and guiding you towards your destinations. But all you have to do is hold on to the handle, right? It's blind people describe it. It's as simple as holding onto someone's arm. Every blind person can do that. You can do that
Yeah.
So it
if you
sounds
close
like
your
this
eyes.
isn't just a blue sky AI project. This is based on a great deal of human factors research.
Human factors research and real world experience. I shipped one of the leading navigation products for the blind while I was at Microsoft. It's called Soundscape, where we tried to use spatial audio, augmented reality with audio and all kinds of audio techniques and haptic techniques and movement techniques. And it is one of the most widely used navigation technologies amongst the blind community today, but it's still only augmentative to the cane or the guide dog. It doesn't replace that need for physical presence, for physical interaction, body to device, to environment, to, the proprioceptive experience of you in your environment. It all really comes down to that.
So I have a question though. I mean, if AI had not existed, could this be made possible? Or how did AI's progress exactly help you to make this device more useful to you and the people in the blind community?
Yeah, I dreamt of a device like this, and a lot of other people have for a long time, right? And I think there's a number of things that, like, the physical guidance is possible, and I think would have been possible with more classic robotics to an extent. And one of the AI capabilities, which people don't necessarily consider, it's not on the front end of LLMs and so on, but just simple things like computer vision and semantic segmentation. Nobody would have called that simple 10 years ago, but we do refer to it as pretty standard today. That's the core mobility. That's the ability of the device to guide you in an environment in a straight line, avoiding obstacles, avoiding walls. You can, using semantic segmentation, make sure that when you walk on the sidewalk, you don't go on the grass, you don't go on the road, things that are maybe not three-dimensional, but you add semantics, you understand them. Those technologies have been evolving quite significantly over the last number of years, and that the combination of those technologies will have brought us to a place where we have a mobility aid that it has at par, if not a little bit better than a guide dog, at least in some capabilities of the dog. Yeah, when you come to saying things like, I can say to my dog, find the door, or find the curb, find the APS button, then you're starting to get to interactions where you need a bit more intelligent, a bit more scene understanding. That will have been harder, although, we had computer vision, we had voice recognition and so on. I think what we have, what the massive unlock with LLMs, vision language models, VLMs, and the capabilities that those present is that generalized understanding of the scene. And what I often refer to as spatial reasoning, where you can look at an environment and reason about the environment. You can understand relationships between objects, but you can also semantically say, one of the demos that we have with Glide is, you'd stand somewhere and you'd say, "Hey, Glide, guide me to the bathroom." But
Mm-hmm.
there's no bathroom in sight. But with semantic reasoning, it can realize that there is no bathroom in sight, but most bathrooms are down narrow corridors somewhere to the side. So it will look for something in the environment that will give it clues as to where that bathroom is. And we'll say, let's go down that way and see if we can get more data to validate that hypothesis, right? And now you're starting to get to an agent, a physical agent, that has the ability to reason, to hypothesize, to make a movement, to validate its hypothesis, go through that loop. But it's because it has a physical presence that allows it to move, allows it to interact with a person that's part of that decision-making loop, that I think that is the massive unlock that we are seeing right now that I think the timeliness of these technologies is really going to is really accelerating what Glide can.
Hang on here. When you talked about this hypothesis, I don't see bathroom around here, so that might be around the corner. Is that the person, the blind person, or that the Glide itself would think of that?
It could be both, but a spatial reasoning model can already make these kind of hypotheses. Remember, I am not looking for the spatial reasoning model to define the whole route. It doesn't have enough information to define
Right.
the whole route.
Okay.
All it needs to do is hypothesize the next step, right?
Yeah.
So the next step is like another example which we've been playing with is I'm getting out of a plane and I need to get to baggage claim.
Yes.
Okay. So the first step I have to do is to decide if I'm in a long corridor, right? The long line of gates. The first question is, do I turn left or right? Right? I don't need a whole route to baggage claim yet. I first need to know if I go left or right. Right? And so, do I have enough information in the environment? Could my agent look at some signs, look at some people, look at some environmental cues to make that prediction? Is it the right thing to do is to turn left or right? The agent could even go up to the airport's website and look up the airport's map, right? And say,
Yeah.
okay, I think I'm near gate 7 and it looks like baggage claim is over north, so I need to turn this person to the right. Okay, but the outcome of it is only a direction. I just need to go right, and once I start moving in that direction, I can gather more information and validate or invalidate that hypothesis. The worst thing that can happen is that I turn the wrong direction.
Yeah.
And I could turn around, right?
Yeah, no, this is fascinating because what you're saying is that you are not looking for the perfect solution at the very beginning. You're talking about how the machine, in this case, Glide, and you, human, actually
Yeah.
collaborate to come up with the reasonable steps, step by step, to get to reach the objective. Is that correct?
That's 100% correct. And the other interesting part is the more we do this, right, the more data we collect from these micro decisions. Yeah. And we improve, fine tune, and develop the spatial reasoning model to make better predictions, right? Because think about the number of nodes that we are going to start having, right? We're starting to roll out glides to blind people in the next few months. By the end of this year or early 2027, we will have probably around 1,000 nodes across 3 different countries in multiple cities, mapping and collecting motion and vision data in a wide variety of pedestrian environments, right? And that data is gold dust for spatial reasoning models to learn and become better and better at making those predictions. Yeah, so you can see how that then becomes a loop of that
Yes.
physical movement in the
Feedback loop.
environment is
Yeah.
actually building up the AI capability to do more.
Yes.
But you mentioned several different kinds of models here, from rather traditional vision processing to VLMs to spatial reasoning models. Do you have all these different things in a pipeline in the system, or is there one end-to-end model that covers all of these functions? Or maybe you could walk us through kind of what's the structure of the models in the system?
Yeah. The one direction that you heard me not saying is that we are going to have one vision language action model that's going to figure it all out and magically produce an outcome. We've definitely taken the approach of a layered architecture where we can understand the purpose of each architecture and ensure and have full transparency as to what goes on at each layer. And so and things are still adjusting, I would say, Ron, but at least where the architecture currently stands and where the implementation is, we have a lot of the you know high frequency processing on device, right? Actually, the lowest layer of simple, well, it's nothing is simple here, but it's a device that uses cameras, and it uses depth cameras and RGB. That's the main input of the device. We don't have lidars, and it has all the other robotic stuff like IMUs, odometry, and everything else. And we use classic robotics at the bottom layer. It's classic deterministic robotics that we've been using for decades. Yeah,
Right.
we create a point cloud of the environment, figure out where the obstacles are, where the drop-offs are. We actually developed our own planner, because one of the cool things about Glide is that it doesn't actually have a map. Every other robot requires a map. Glide doesn't have a map, and so it has to figure out how to guide the user in real time. So that all runs on the device. Classic old robotics,
Yeah.
overlaid by computer vision for semantic segmentation to understand the texture of the environment, whether it's basically traversability. What's a traversable path? What's a walkable space? And what's not a walkable space? Yeah, if I'm on the sidewalk in the park, I want to stay on the sidewalk. But if I'm on the grass, I want to walk on the grass. Yeah, that's a semantic understanding. So that's already a level of AI that runs very fast on the device. Above that, we have some initial object recognition of things that you would want to detect in the environment, but are within a very strict domain. We call those primary targets, like doors, escalators, steps, road crossings, things like that. That all runs on the device. And then when we want to open up to that more spatial reasoning, hypothesis-driven navigation and wayfinding, that's when we start to go up to the cloud, and where the frequency, like it's not happening every second, right? Like a query happens, there might be quite a few seconds or even minutes between one
Right.
query to the next. Yeah.
Yeah.
Where we have that higher order reasoning that is basically an agentic loop that runs between the device and the service in the cloud. We can see in the future more and more of that coming onto the device. But one of the things that is important with Glide is a device that is cost effective. Like Glide is not a $20,000 device. It's a $1,500 device. I can't put a large NVIDIA chip in there, both from a price perspective, and I can't afford that from an energy perspective, because I need a device that runs 6 to 8 hours non-stop. No NVIDIA chip can have a big enough battery that can go on a plane, for example, because there's limited size of battery that you can have that can run for 6 to 8 hours. So really ensuring that those considerations are taken into that we take those points into consideration.
Does separating the layers like that also allow you to train them independently and possibly to even change algorithms?
Correct. And the lower layer collects the data, and we have the pipeline where the data from the day is pre-processed on the device, then pushed out to the cloud, and go through classification and self-training and everything to train the models in the cloud. That then improves both the reasoning models in the cloud, and therefore improving the whole fleet, and also improving the local models, the segmentation models, and the capabilities on the device, which we then distribute the updated models through over-the-air updates to the fleet on a regular basis.
So are the models in the cloud actually continuous learning, or are you just doing frequent retraining?
At the moment, they are frequent retraining, but hey, we are building our physical AI team. We call it our embodied intelligence team right now, and I think the opportunity there is broad and expansive in real-time learning models. That the agentic loop learning model, when is it the learning for the whole fleet? When is it a learning for a particular environment? When is it a learning for a particular individual? Maybe they have specific needs as well. So I think, yeah, we are in the early stages um, of building out the whole, building out the future, if you like.
Right. I'm glad that you actually walked us through because I cover a lot of autonomous vehicles, and the AV industry tend to be really sweeping claim of we've got this safest car that it's much smarter than human-driven cars is their pitch, right? But what we are talking about here with Glidance is more or less of the layered approach, sort of gradual stepping up, but also collaboration with the person who is using Glide. It's a fundamental difference in terms of what we expect AI to do. Eventually, it might be get there, but it's like there are a lot of steps that you're talking about.
But the beauty here, you're spot on, Junko. And the thing is, right? We often think if, like as a blind, you think that a blind person just needs a device that takes them from one point to the other point, right? And the blind person just holds the device, their eyes closed, and they just follow where the device is going. That's not how a blind person wants to be. They want to feel in control. They want to have full agency, a sense of agency and confidence in their environment. They want to be the ones that are driving. The device is an autonomous guide. Like it has the intelligence to guide and drive, but it's always subject to the individual. Most of the times, blind people are in environments that they are fairly familiar with, and they will drive. They know when to take turns. They know when to do, but they need the help of the device. They need the help of the device to help them. Like I walk along a corridor and I want to turn right. I indicate to the device that I want to turn right, but it might be premature because I haven't reached the right turn yet. So the device will, we call it intelligent disobedience. It will disobey my command, but it will tell me, I got your command and I'll turn you right as soon as we can. And then it starts turning and you feel it. It's all very, very intuitive, but it's an interplay between the person and the device. Even the example we talked about earlier about finding the bathroom, the person could help the device. Hey, can you find a corridor that might lead to a bathroom? Like it could be more specific, right? They can work together to problem solve. And the beauty of that is that Glide doesn't have to be fully autonomous out of the gate.
So the model here is really not an autonomous taxi. It's an enhanced guide dog.
Yeah. And over the years and over time, as Glide becomes more and more capable, and maybe there'll be other form factors that the spatial reasoning platform will enable, the industry will be able to address broader needs from people. Like a blind person, some blind people can really understand the environment and get around fairly confidently with a guide, fairly rudimentary capabilities. Other people have really great difficulty with orientation. They have to memorize every single step on their route. It doesn't matter how many times you train them. They don't really know where they are on a route. They just need to know the next step. And so the demands on Glide are increased in those kind of situations. Yeah. But eventually, as we build out the capability, we will be able to do more of that. And then now starting to go to places that are unfamiliar and guiding people in places that neither the person has been to before nor the Glide has been to before, and they have to figure it out together. You can see that over time, the capabilities that Glide can bring to the equation enable the person to do more and more, even if they have very, very rudimentary orientation and mobility skills.
I've heard it suggested that some people who have never been sighted simply have no concept of a three-dimensional space. Their world is almost scripts. Is that what you're trying to describe?
I wouldn't say that. I think blind people have an unbelievable three-dimensional mental map of the space. They could describe to you the structure of an underground station and how all the corridors relate to each other in three-dimensional space because they're not restricted to vision.
Interesting.
So their mental map, our mental, include myself in those there, our mental map of the world is a lot more sophisticated than most people, I would say.
Mhm.
But only a subset of us have that capability, and especially people who lose their sight later in life, which is the great majority of blind people. Great majority lose their sight after the age of 50. Okay? They haven't had a lifetime to develop those skills. A lot of people naturally don't have strong orientation skills. Like orientation means I know where I am and I know in which direction to go. Yeah. Um, and so people without strong orientations, and I'm not even talking about skills. I'm talking about capability. Like some people just don't have the intellectual capability to have strong orientation. Yeah. That you know people who say I have no sense of direction. Plenty
Mhm.
of those, right? And if you're blind and have no sense of direction, that compounds. Yeah.
Mhm.
And so that's where something like Glide, as it becomes more autonomous, more point to point, more directive in its guidance, it will enable more and more people to build up their mobility capability. And the other amazing thing is that once they actually start moving in the environment, they will start to build up those skills as well. So it's a virtuous cycle for the individual as well. It really lowers the barrier to let them start moving.
Can you see a time when Glide could provide services beyond navigation, like facial recognition, for instance, or context cues about what's going on around them?
Yeah, no, absolutely. And honestly, some of that we already get. Nothing comes for free, but some of that we already get for free from the VLMs and LLMs.
Mhm.
I mean, thanks to those technologies, Glide can already read signs and learn symbols and learn what an arrow means and all kinds of things that even 3 years ago I wouldn't have dreamt that we would get to. So
All right. I think this might be a
yeah.
good time to talk about the functional blocks. What's inside Glide? Can you walk us through, Amos?
Yeah, so we didn't really describe the product itself and how it works. So basically, can I just give a physical and then we can go into the inside? The
Sure, that's a great
the f-
idea.
the physical is its Glide basically has two wheels on the ground, a base between those wheels, and then a long handle that extends at 45 degrees, and the user holds the handle. So what happens is that the wheels would be about 2 to 3 feet in front of the user's leg. They hold the handle and they begin to walk. And as they begin to walk, the wheels autonomously steer the way. So basically, all they have to do in order to sort of walk is to they feel the direction that the device is going in, and they follow where it's going. So if you're walking along on the sidewalk and there's a tree in the way, Glide isn't going to take you to the tree and say tree. It's just going to avoid it, and so it will just gently steer you to the right. You'll follow it, and then it'll line back up with the sidewalk. Very smooth. That's why we call it Glide, because when you walk with it, you glide. It has two cameras built into the handle, so at the top of the stem. One camera is facing at 45-degree down so that it can capture drop-offs, trip hazards, surface level uh, precision. And then the other camera is facing forward and slightly upwards to have a much longer range for planning, for detection of the broader environment, but also to capture of what's called overhead obstacles, which are things that can hit your head. like tree branches and store signs that are hung too low and whatever it is. The big accident, cause of accidents for blind people, overhead obstacles. So those are the two main sensors. The compute is an NXP IMX95 chip that's in the base of the device, and that's really the Linux machine. It has an NPU, which is a quantized. It's basically an inference engine for quantized models, where we run our local AI models. There is a chip obviously in the handle that manages everything, all the cameras, the camera input, also the buttons, there's microphones, speakers. There is also a TOF sensor at the back of the device, a time of flight sensor at the back of the device, that the device can see where the person is standing, so that it can ensure that there is clearance not only for the device but also for the person when you walk. So that's generally the physical layout of the device. We have connectivity in terms of Wi-Fi, Bluetooth, as well as we decided that LTE, like cellular data, is pretty critical to management of the fleet and diagnosis, and also making sure that people can get out of situations and that we can see and understand their device remotely. And that also helps with getting of course the VLMs, VLM access through the LTE modem, data access if we need to pull down maps and other things. So yeah, the LTE is an essential component. One of the things that we decided that we don't want to go and rely on the user's cell phone for connectivity. And that's because, again, going back to the fundamentals here, a Glide is a mobility aid. It's not an app on the phone. You want a person to be able to pick up the device and just walk, and you don't want them to be figuring out why the phone is not connecting to the device and pull up the app and do it just needs to work, right? And so we made sure that this is not an extension of the phone; it's a standalone device.
As you share more tasks with the cloud, will LTE still be sufficient, or will you have to go to 5G?
LTE today gives us much more reliable coverage. 5G is definitely progressing, but generally coverage, we have the ability to go to 5G, but all our tests to date, again, we are not uploading video at any high pace. We're basically uploading an image and a prompt, and maybe a very short audio. So that is not the limiting factor right now. But it's a good question, and it's possible that as we move forward and as we lean more into these technology, I think a lot is going to be determined on how much inference we can do on device. Again, it's all trade-offs and cost, speed, coverage. It's currently LTE as a solution.
Really interesting systems problem.
Right. And I'm also not saying we've got all the decision 100% right. I mean, one of the things we have to understand is that my goal is to get these devices out there as quickly as possible and learn as fast as possible. And so sometimes you just have to go make a decision and go with it. And, I want Glides out there. I want to see how people use them. I want to understand where the limitations are. As a startup, as a company that's is eager to change the world one step at a time, we need to be out there and learning.
Understood. You mentioned when we talked about connectivity, LTE, for example, you mentioned it remotely connects to something. I mean, are we assuming there's some kind of remote operators out there just in case for some assistance?
When I say connecting to basically, first of all, it connects to our platform, which continues to monitor the fleet and make sure that everybody's device is in good shape. And if they do report a problem, our support team can go into the device, look, peer through the camera, or look or peer through the look through the system and understand what might have gone wrong. Maybe the cameras got smudged, yeah. But that definitely enables the possibility of another person coming into the loop to help the blind person.
Yeah.
Yeah. And that is something that we believe is going to be a very powerful aspect of the solution. It could be family, friends, it could be
Yeah.
someone from Glidance, or it could be third-party services that can come in and support a person, help them get out of a situation.
Very good. Um, Getting back to my experience with covering autonomous vehicle, I'm kind of curious, what sort of things do you consider for Glide to be edge cases that you need to learn? What would you consider as corner cases or edge cases for Glide to actually function smoothly?
So I'm going to start with reliability.
Good.
And
Yeah.
okay, because it's safety and reliability and consistency are the things that are the foundation. Everything else is fine, right? So for safety, one of the things that we have to define what are the critical safety factors, okay? And I don't know if it will surprise you or not, but a blind person walking into a wall is not a concern for me. It will hurt, but nothing will happen to them.
Okay.
What is a concern for me is drop-offs on the side. I'm even not so concerned about a drop-off in front, because a drop-off in front, Glide will be the first to fall. Okay? If there is any issue, like Glide is a physical presence in front of you, and you will feel that drop-off even if the whole device crashed, you will feel that drop-off, right? But if a drop-off creeps on you from the side, and that drop-off could be the edge of a sidewalk, but more concerning is the edge of a train platform, which is, we all walk at train platforms because we all use public transportation all the time.
Yeah.
So for me, those drop-offs at the edges are really edge drop-offs are the primary concern. And so that's where we have put a lot of effort into the downwards facing cameras, also understanding where the camera is losing certainty and conveying that to the user, where the camera has some like it could be a physical smudge on the lens, it could be lighting, it could be things where the camera is uncertain that it is able to detect the drop-offs on the sides. And as a final fail-safe, we've created a watchdog in the device that all else fails, if the device stops working, even if the battery cuts out, the device will sound an alarm. So there's a separate circuit, because what you want to make sure is that the user knows that they can't rely on the device at this stage. Yeah.
Oh, yeah.
How they get out of the situation, that's the next step. But the first step is that they don't continue
alarmed.
walking
Yeah.
thinking that the device is guiding them when it's not guiding them.
Not. Good
Yeah.
point. Yeah.
So a certain amount of syntactic understanding has to be local in the device, it sounds like. No, that's not a line, that's a curb. Or this is the edge of the platform and there's a newspaper shielding it, that kind of thing.
It's semantics, it's syntactic, but it's also physical. Like I know the plane that the device is on, and I'm seeing something that is lower than that plane.
Mm-hmm.
That's a drop-off.
So you can do that with physical understanding locally.
I can do that both with the computer vision as well as the depth image from the cameras. And when I have either disagreement between those two, or that one is saying that it's not able to perform its duty, then I have a fault situation or a risk situation that I have to inform the user about. Yeah, so I'm trying to use multiple redundancies around the critical points, and the key here is to inform the user. And it's a bit different from self-driving cars. We never really tell the user you can ignore, you can go to sleep because we're driving. We always tell the user that they have to stay alert. Even, I can't remember if I mentioned that, but even the wheels of Glide are not motorized. It doesn't pull you. You push it forward. So you can stop at any time. You can walk, take a step back. You
Yeah,
are
that's different.
always in control
Well, yeah,
of
yeah.
of the experience.
That's the main difference. Yeah, that's true. And especially when you
Yeah.
use AI, happen to be like AI could be supremely confident and moving into the really dangerous place. But that would not happen because this is a collaboration actually between the human's decisions and the guidance by the glide.
Yeah, and again, that's where we have the hierarchy of risk versus, like, if the AI is extremely confident that the baggage claim is to the left and it got it wrong, the consequence of that is very minimal,
Yeah.
right?
Yeah.
Versus a drop off, or when you cross the road and we want to find the up curb, that's the place where you get off the road. That starts to get more consequential, so we put a lot of redundancy around those situations.
I see.
But
Yeah.
like I said, when a person just walks around in a, I don't know, in a conference or in the office block, the good thing is that Glide is very reliable at avoiding obstacles. But if their shoulder touch the edge, the wall at some point, it's not the end. And we'll improve better. I don't want to sound like I don't care. Of course I care.
Well, you
But
care.
I'm talking about a hierarchy, right?
Yeah.
Of
No,
concerns. And as a blind person, we are covered in scars, right? We have scars on our forehead and scars on our shins and scars because we bump into things. It's part of life. Yeah. And so we're going to reduce those bumps, and we're going to help a person be more confident when they're out and about. But we just really do have to be focused on the risks that really matter.
you mentioned the various sensors in the glide. You mentioned camera. You mentioned even TOF, right? Time of flight. Do you use radar as well?
Radars?
Yeah.
Not at the moment. We have experimented with them. And we may bring them back to solve certain problems, but we're not using them at the moment. They require a lot of movement. It's like we don't move quite fast enough. Like the thing with radars is that they work well when there's movement, and they
I
work
see.
at longer distances than
I see.
what we are dealing with. So, like, there's just the physics of the radio waves
Gotcha.
put
Yeah.
some limitations on the use. We also moved away from the idea of using a LiDAR again for it's mechanically more fragile. B, it is it does take quite a bit of power, and also we don't really need that precision that you get
Right.
from LiDAR. We don't need to see a car coming at a certain speed from 200 meters away.
Right. Right.
Like we're not driving.
Yeah. No, that's
Yeah.
no. Yeah.
And
Yeah.
it was going to add a whole layer of complexity. Having said that, it doesn't mean that we won't look at, as lidars become more usable in consumer products. That could be definitely something we'll look at.
You, you know, during when you were explaining it, what's inside the glide, you did mention the three things that are very important in designing glide. That was one was reliability you mentioned, the other one was security. What was the third one?
Consistency.
Consistency. These are the top three factors you need to consider in creating physical AI devices like Glide. Anything
Yeah,
else?
consistency is important. At the end of the day, it's a tool that a user is using,
Right.
and the user needs to know what to expect. The user is an intelligent being that will work around most limitations. But if the device behaves differently in situations every time they encounter them, they
Yeah.
won't know what to expect from the device. So consistency is more important than trying to automate everything. I'll give you an example that we were just dealing with just yesterday. Yeah. Sometimes the path is blocked,
Yes.
but sometimes there is a narrow gap that if you really wanted to get through, you could sort of go sideways and maybe even pick up the device and squeeze through. And we're trying to say, is there a difference, and does the user now, we can't at this stage reliably distinguish between those two and provide the correct information to the user every time. But we really wanted to give that. But at the end, what we decided is just tell them that the path is blocked. They can put their foot forward and see if there's a gap. Like, don't try to give them information that you will get 80% of the times right if you are not. Yeah. Like, try to give the information that is going to be consistent. And the user will figure out the rest. Now, over time, when we can enable more capabilities to be consistent and reliable, then great. But consistent and reliable behavior is more important than trying to do all the magical stuff that we believe AI can do, but not always very consistent or reliable.
That must put some interesting pressure on your retraining team to arbitrate between retraining frequently and maintaining consistent behavior.
It is, and it's part of our evaluation platforms that and our test sets that we run our models through is really to look for consistency, understand where the changes happen, and ensure that they provide more nuance, but are not starting to move the goalpost on the user. That's and if they are moving the goalpost, then we need to communicate that. Yeah. And that's part of the thing what I mentioned right in the beginning is that I can't just let a vision language action model figure it out for itself, because I can't really guarantee any degree of consistency.
So you can't just settle for correctness. You have to look at the impact on the users.
I do. If I move the goalpost every release, they're not going to know how to trust the device. And, like I said, they figure out solutions to their navigation problems using the device. And if I change how the device is working every time, then they're going to have to figure it out all over again.
My last question to you, Amos, is
Yeah.
that, we have a lot of dreams, how we want to improve the systems, but what do you see as more immediate challenges you need to solve? If you asked Amos, we'll give you a magic wand. The three things you can wish, what would that be? What would those three would be?
I mean, the first thing is by far the risk, and the determining factor is just generalization. Like, is my device and architecture generalizing enough that most users will be able to use Glide in most environments? That's a huge ask.
It is.
From a robot. And there's no other robot that you'd put that ask on, right?
No, that's true. Yeah.
So that is really a lot of our work right now, is to understand the generalization, especially on the AI platform. But the whole stack, does it generalize? It starts from, the wheels are going to work in any environment. But focusing on the AI, that generalization is definitely the biggest factor, the biggest thing that will determine how fast and how broad we can go. And that's generalization even on the segmentation, or not I'm not talking about the completely open-ended VLM queries or find the bathroom, right?
Yeah.
I think then the next thing that comes after that, which is the big thing that everybody wants, is they do want guided navigation, right? And so turning that agentic loop with spatial reasoning that can pull on maps into a solution that can actually enable a person to say, hey, Glide, there's a Starbucks on such and such a street. Guide me there. Yeah. And that's just from a value perspective to the users and the blind community is a massive unlock, and we will get there. And I know that the market is super excited and eager for us to get to that. So I would say those are the two biggest items that we need to that keep me fired up and sometimes awake at night to make sure that we get right.
You get there. All right. Very good. Well, thank you so much for your time. This was a lot of fun. I think you sort of nailed that what has not been actually resolved by AI, even though everybody wants to paint physical AI is the next big thing and things are pretty much all solved, but that's not it. It really we need to take a more judicious, vigilant steps to get there.
Yeah, I agree, but I also I do feel that AI behind the screen is in a cage. You need to get it out there and into the real world and let it be part of that, a part of our life, and that's where I think the physicality that comes with an intelligent agent is really a magical moment that we're going through right.
Very good. Thank you so much for coming to the show, and
Thank you.
we will talk soon. This episode is sponsored by NXP Semiconductors. NXP offers a comprehensive combination of advanced AI and machine learning solutions, sensing technologies, edge computing, robust connectivity, and networking solutions. Critical to the development of physical AI, the company also provides integrated security and functional safety. Together, NXP is powering the brains, muscles, and nerves of autonomous robots. Learn more at nxp.com/AI.